Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So today's problem is continuation of momentum playlist. Please read the description about prerequisites and previous problems and the playlist links. So for you it's good to get the maximum out of this video. And this would be again about the law of conservation of momentum. This time they said that there is a projectile, and we of course know that the projectile thrown under angle alpha will fly and it will be parabola, and they tell us that in the top point of the parabola the speed is v0, and v0 they tell us what it is, 10 meters per second. And they tell us that at that point it is divided in two masses. They tell us specifically that one mass is 10 kilo and another mass is 15 kilograms. So 10 and 15 kilograms, so obviously original mass is m1 plus m2, and this was in the beginning, but then in the end this is m1 and m2. And they tell us that the first particle moves exactly in the same direction with v1, and they tell us what it is, 25 meters per second. Alright, and they obviously want us to make our life a little bit more complicated. That say, okay, this is the maximum point, and they give us h, and they tell us that h is I don't know, 100 meters. So this is the Earth, and this is the top point of parabola, and now I described you the whole problem. And they want us to find out the distance, because what will happen actually, this would be, it's flying. Now the first will be flying this parabola, and the second will be flying with this parabola. So it would be like two bodies. One body is with the initial speed v1 under zero angle, and this would be with the speed v2. And they want us to find this distance. This distance, d, is what they want us to find. But this is a little bit extra, and h is a little bit extra. Let's start with an obvious thing about momentum. Momentum here is very simple. m1 plus m2 multiplied v0, and this is all happens along this x-axis. This axis, and although this is a vector law of conservation of energy, I will write it along x. And this is before explosion, and after explosion it's m1 v1 plus m2 v2. And we basically immediately have m1 is known 10, m2 is known 15, v0 is known 10, m1 is known, v1 is 25, m2 is 15, and v2 is unknown, so v2 is the only unknown thing, and we can basically solve it right away. And how we solve it, we put it this way, they put it this way, I will split it, change left and right side, and then it would be, and when I will change it, I will simultaneously move this away to here, so it would be m1 v1, and I immediately obtain that v2 equal m2, and here would be m1 plus m2 multiply v0 minus m1 v1. And right away I can obtain the numbers, I can keep this as a formula because they want us to find the distance. But this is such a simple case. It's important to keep characters up to here, and I explain why. Because if I put the numbers, I can obtain V2 right away. And M1 plus M2, it would be 10, plus 15, it would be 25, multiplied by 10, and this is what this happens. M2 is 15, and I put minus, and M1 is 10, and V1 is 25. And right away I see that it is 0. So basically, in this particular case, what will happen? The whole momentum of this 25 kilogram traveling with this 10 meter speed will be given to the mass 10 kilometers, but it travels with 25 meters per second. So for the second chart, for the second part, mass 2, there would be no momentum left, it would be 0, and that means that speed would be 0. And then basically what will happen is that at h, that it is 100 meters per second, the second body will fall straight in. This parabola will become like the less speed V2, the more parabola becomes like this, and if V2 equals 0, parabola is basically free fall down, and the M1 will be traveling like a parabola, and then it's a problem about finding this distance, which is basically would be the time. And time, if you recall, is defined, and you have to watch this two-dimensional kinematics playlist. I talk about this in details, but basically time for this h, we can say h equal gt squared over 2, because vertical component and vertical motion determines the time when it falls, and t equal 2h over g, and this would be this, and t equal to h over g, and then this distance for the first body would be v1t. d equals v1t. So basically that's it. We have to plug v1 25, find the t. T would be square root of 200 over 10. T would be square root of 20. Square root of 20 is probably 4.5. So d would be v1 is 25, and v1 is 25, and t is 4.5. So it would be roughly, distance would be 25 by 4.5. Well, it would be about 110 meters. So in 4.5 meters, if the body moves with the 25 meters per second, it will roughly cover 110 meters in this direction. So the first body will fall, the second body will move in the parabola, but it will be along this direction, it would be free fall. Same time, they will be on the same height all the time. Here and here and here, and finally they reach the ground at the same time. And this would be the same time. This time is 4.5 meters, and along the horizontal axis, the first chart will move with this constant speed, and this would be it. But we don't have to make this assumption about the 0. We can basically say that this is it, because, for example, if I change them, M1 and M2, if this would be 15 and this would be 10, right? Then everything would be very different, because this would be, the sum would be the same, 25, V0 would be the same, 25, but M1 would be 15, not 10. And then if I multiply by 25, and m2 would be 10, not 15. In previous example it didn't matter because this was 0, but right now it would not be 0. I can take 25 factor out, and 10 minus 15, it would be negative. So the velocity would be negative. If this mass is bigger, 15 multiplied by 25 is more than initial momentum of original projectile. That means it will carry too much momentum, the first mass. And then this mass will be moving this direction. So this picture actually would be wrong, because actually what will happen is the first will move here, but the second one will move here. And basically what that means, that we don't have to plug the numbers right away. We can, but it's not necessarily required, because as soon as we know that v1 and we find v2, we can say that the distance is this distance d1 that covered by the first chart, minus distance d2. So this is d1 and this is d2. And I don't care about the sign. The sign will be obtained on its own. And then I say that d1, I will put it here, d equals d1 is v1t, right? And d2 is v2t. And so all I can have, let me put this, wipe it out. Time I will leave as this, because time is everything along this vertical axis for these two projectiles, two charts would be the same. But I will basically say that the distance would be this minus this. So it would be v1 minus v2 multiplied by t. And I can plug here those numbers, v1 and minus v2, I put it here in the form of this m2. I will have to carry this here, m1 plus m2 bracket v0 minus m1 v1, right, bracket, and multiply, and I can multiply here by the same t. So I can multiply by 2h over g. And this would be my formula. I can write it here in a little bit more polite form, because so the distance would be bracket v1 minus v2, and v2 would be here m2, and this would be m1 plus m2, right? v0 minus m1 v1 bracket square root 2h over g. And then this is my result, and then this result I will plug those numbers. And if I receive here, this would be like in this example, this would be negative. So negative minus negative would be positive, so the distance would be actually bigger, because this would be traveling this way and this chart would be traveling that way. So basically this was a combination of the law of conservation of momentum and also some previous knowledge about two-dimensional kinematics, about the body that's thrown on the angle alpha, which is we don't care now, because we care only that it's like here in the apex of parabola, and we have a speed and we have the explosion here. So basically that's it, and I hope you liked it. Subscribe, bell, question, and I see you next time. Thank you.